Okay, now we're talking. So today we're going to go over 6.4. It'll be a short little lecture, not that much on it. I'm gonna I'll get to that in a second. So before we get started, I'm going to repeat what I've repeated for the last 3 weeks. Your final is going to be Friday. It's going to be open 8 to 5. I've sent you an email about it already. You need to get it done at that time. If you can't, like I have a few students who don't get off work till 4 or 5, email me and I don't mind opening it up, that evening. That's not a big deal at all. So if I need to make accommodations, please let me know. You just need to let me know beforehand and not Saturday or Sunday. You got to let me know before you get there. So not a big deal. So that's, it's about 40 questions. It's multiple choices, just like the test we've been doing so far this semester. So not a big deal. Excuse me. It does replace your lowest test grade. So whenever your final replaces your lowest test grade. So let's say you bombed one test, the final will replace that. The final will replace that, but it still counts as a grade. So it's not that it still counts as the grade for your final. So it'll just count really kind of double if it replaces it. If it's lower than all of your test grades, it just won't replace it. Okay. So if you made like all A's and you make a B on the final, it just won't replace any of those A's. Okay. Not a big deal. A lot of us typically in this class, there's one test that we just need to get replaced. And the final helps that out whenever you've done well, except for just one test. Okay. It is cumulative. You need to look over all your tests. That's the best way to study for it. And then what we went over yesterday and what I'm about to go over today is also going to be on it, just not on a regular test, of course, because all of those are done. Okay, great. So let's get to 6.4. This won't be long. We're going to talk about matrices. We're going to talk about the inverse matrices and the identity. All this is on the calculator, so it makes it a lot easier. If you want to look at it by hand, you're more than welcome to. It's in the book on how to do this by hand. But yeah, have fun doing that if that's what you want to do. Okay, 6.4. So 6.4 is over the inverses of matrices. And so what are the inverses? Well, let's just talk about inverses that we know already, like the additive inverse. If I had like 5, its inverse would be -5. If it's addition, the additive inverse, I should say, would be -5. And that gives us 0. So these are the identities. And this is the inverse. So with addition, you just did an opposite sign, right? If it was 5, the inverse would be -5. If it was like -3, the inverse would be +3. And the reason it's the 0 is the identity is because with addition, when you add 0, nothing changes, right? If you had 5 plus 0, it would give you 5. So the identity just does not change with the operation. So if we looked at multiplication, let's use the same number 5, but now we're going to multiply. The inverse is going to be 1 over 5, and that equals 1. And again, with multiplication, when you multiply any number by 1, nothing changes, right? And then when you multiply these together, you get the identity. That's why it's called the inverse. Remember, you just flip it if it was a fraction, and it gave you the inverse. Okay, well, with matrices, it's the same kind of thing. Now, we're going to use some notation here, though, before we actually get to it. If we have some matrix A, and we multiply it by its inverse, now we're going to notate it this way, a to the -1, it winds up being its identity, okay? It winds up, oh, you know what? Composition, we did composition too. Remember whenever we took the composition of inverses, it gave us x. It's because x was the identity with compositions. Okay, never mind. I know that was just a side thought. I forgot something that we did learn this semester. But the composition of inverses, or composition of inverses, gives us the identity x, which on a graph x is the identity. Anyway, back to this though. So if you have a matrix and you multiply it by its inverse, you wind up with its identity matrix. So we're actually going to start by defining what the identity matrix is first. Okay, the identity matrix is always a square matrix, which means we have to have square inverses as square matrices to start with. It's a square matrix, and it's always consists of zeros and ones, but the ones are always diagonal top left to top right. So if we looked at, let's say, a 3 by 3 inverse, it would be 1 0 0 0 1 0 0 0 1. Okay. Or if we looked at, let's say, a 2 by 2, because I'll show you kind of an easy example of using that identity to show that nothing changes. When you multiply, remember, look, when you multiply matrices by their identity, nothing's going to change. It's the same with multiplication. You multiply like 5 by 1, you get back 5, nothing changes. So let's stick with this identity matrix for the 2 by 2, and it'll bring in an example we did from yesterday, multiplying 2 by 2 matrices. So let's say we had, let's say, -3, 4, 1, and -7. Okay. And let's say we multiply this by the identity. Okay, so we have a matrix. We'll call it A. It doesn't matter. But we're going to multiply it by its identity. And what we're going to see is we're going to get the same exact matrix we start with because we're multiplying by the identity. Okay, now if you remember this, we take this first row, drop it into this first column. I'll put it down here. We wind up with -3 times 1 plus 4 times 0, right? The 4 overlaps with the 0, -3 with the 1. Then we take the same row and we dunk it into the second column, and we would get -3 times 0 plus 4 times 1. No more spots to dunk, so I'm going to stop that there. Then I'm going to go down to the bottom row. Same thing, so 1 times 1 plus -7 times 0. And then 1 times 0 plus -7 times 1. So let's simplify this out. Now, what's nice is we have a lot of zeros, so that goes away. So this first one, -3 times 1 plus 4 times 0, that goes away. And you wind up with -3. -3 times 0, that goes away. 4 times 1 is 4. 1 times 1 and -7 times 0, that's just 1. This goes away and we get -7. Hey, hey, hey. That's what we started with, right? -3, 4, 1, and -7. Okay, pretty cool. Okay, so when you multiply a matrix by an identity matrix, now look, it has to be square. Okay, you have to have a square here. It does not work if it's not square. But when you multiply the matrix by the identity matrix, you always wind up with the what you started with, because it's an identity. You're multiplying by an identity. Now, the next part of this is actually finding the inverse. This doesn't have anything to do with the inverse, but we want to find the inverse. And the easiest way to do that is in your calculator. Your book goes over a step-by-step way of doing it. There's nothing wrong in doing that, and you're more than welcome to do that. But hold on, let me find one that has a nice inverse so we can check it as we go. Oh, excuse me. Yeah. Okay, so let's say we started with matrix A, and I'm going to show you how to put this in the calculator. Let's say we started with matrix A. We've got 3, -2, -1, and 1. Okay, 3, -2, -1, and 1, and we want to find its inverse. So to do that, you pop open the calculator. We go to the matrix option here, so second matrix, and then we're going to edit. Let's just do matrix A. Okay, we're going to edit matrix A, so hit enter. And then now this one's a 2 by 2. I guess yesterday when we were working on these, we did a 3 by 3 here. So 2 by 2. And then I've got to put this matrix into there. So 3, -2, -1, +1. Okay, so I've got now matrix A is our matrix we're dealing with here. 3, -2, -1, and 1. So I'm going to second quit out of this thing. And now it's really, really easy. So if I want to find the inverse, I need to call the matrix to the main screen. So I'm going to do second matrix, bring that to the main screen. Remember, that's our matrix. We already put it in. And the matrix button, you actually press that second matrix. You see how it's x to the -1? Oh my gosh, didn't mean to do that. We're going to press that, okay? And that brings up this inverse matrix. So a to the -1. I'm going to hit enter, and boom, I have my inverse matrix. So 1, 2, 1, 3. 1, 2, 1, 3. Pretty nifty. Okay, so if this is true, when I multiply these together, I should get the identity, right? Remember, a times a to the -1 should be my identity. Now, I know this is going to be true. The calculator did it. The calculator doesn't lie. Well, yeah, the calculator doesn't lie with this stuff. So I'm going to check this to make sure it's true. So I've got these two matrices. 3, -2, -1, 1, and 1, 2, 1, 3. And I'm going to multiply them to see that I get the identity matrix. Because now if I multiply them together, I should get the I. So I'm going to do that. So 3, -2, -1, 1 times 1, 2, 1, 3. Same thing, you know, we've done this quite a bit now. Dunk it in there, and I get 3 times 1 plus -2 times 1, right? Now get into the second one. I'd get 3 times 2 plus -2 times 3. Take this second row, do the same thing. -1 times 1 plus 1 times 1. The last row, I'd get -1 times 2 plus 1 times 3, right? Okay, so let's simplify these out. If you need to pause it, if I'm going too fast, just pause it, right, and catch up. But let's simplify this out. So 3 times 1 is 3 plus -2 times 1, that's -2. So this winds up being 1. This is 6, and this is -6. So 6 plus -6, that's my 0. Excuse me. -1 plus 1, that's 0. -2 plus 3, oh, that's +1. Hey, 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 look. When we multiplied these two matrices together, it gave us the inverse. Now, you can do that in your calculator too, which is kind of cool. You can say matrix A times, and I'm going to bring the matrix back up, but it's inverse. So look, I'm taking A and I'm multiplying it by its inverse. Boom, 1, 0, 0, 1. Kind of neat. We get the same thing, okay? So I just wanted to show you that this is finding the inverses. I'll tell you on the test, it's really easy. All you have to do is pop it in your calculator and then raise it to the -1. It's one of the ways we assess technological learning, okay? Now, if you want to do it by hand, you can fool us and not learn the technology, that's fine. But if you look on page, the bottom of page 631, it gives you the way to do it by hand. And you're more than welcome to do that. It goes on to page 632. More than welcome to do that by hand. Have fun with that. Okay. So for homework from the section, I mean, this is it. This is it. We're done. For homework, we're going to have, hold on. Yeah. Okay. So 1 through 11, it just asks you to multiply those to find out if they're inverses of each other, right? So when you multiply them, if you get the identity, you know they're inverses. Now these will be all odd. The next part, I want you to find the matrix or find the inverse. It tells you to do it by hand. You don't have to worry about that. You do it in the calculator. So 13 through 25, just find the inverse. Yeah, find the inverse. So that's on page 639, section 6.4. Okay, and that'll be the last stuff we learn this semester. Okay, that's it. It's a nice small section. I mean, this This lecture was 20 minutes, right? Not a big deal. So look, we've got 2 more lectures. We've got a lecture Wednesday. Here, I'm going to swing it over to me. We've got a lecture Wednesday, and we've got a lecture Thursday. The Wednesday lecture is definitely going to be, what am I saying? No, both of these lectures are crucial for reviewing for the final. So I need you to come in with questions or email me questions that you have for the final for tomorrow and Thursday. I'm not going to just sit here and spew out. Look, everything we've gone over is going to be on the final. I'll tell you that. I mean, there might be a few things that get cut, but it's going to be pretty much everything we've gone over is going to be on that final. So I need you to look over it. Come ask me questions. Any question is fine, honestly. But if I don't have questions, I'm not gonna have the lecture. I'd rather you just be working on homework and getting prepared for the final. So it's going to be very driven from your questions. So I need you to ask me questions, and that's really how the review is going to go. Okay. If not, I'm just going to tell you, study your test. That's what's on the final. Okay. Okay. Well, I will see you all. No one's in class. It feels weird just talking to nobody, and that's fine. I will see you all tomorrow. Riker, if you're there, hope you had a good day at school. Hope you're doing well this semester, and hope you got that Christmas list going for mom.